Yeah, right. Woo! Last one. Okay, we're going to let M be the region in the first quadrant. Okay, we got a first quadrant. Boom, boom. And we got this curve and this curve. Actually, those are both lines, but we can still call them curves. I drew my first one. It's just a rough sketch, you know. We have our y-intercept, which is 2, and we have a slope that is up 3, right 1. Now let's do our other one. This one has the same y-intercept, but the slope is slightly smaller, and so it has to go underneath it. And then we see a line right here. There's a vertical line, x equals 3, and this makes our region, which we can now shade in. All right. Okay, we do have a volume of revolution. It is generated when we revolve around the axis y equals 1. All right, so we got our visual. Let's get to it. Okay, now this is a washer method. You can tell because the area right here is not touching like perfectly on the axis of revolution. So we're going to have to find two volumes and subtract them. We have to find this volume of the outer one and find this volume of the purple one and then subtract the two. There is a way to consolidate this, but my stews, I'm going to go the long way because I want to make sure everybody understands. Okay, so because we have an axis of revolution that is horizontal, we know that our integral expression is going to be written in terms of x. And because it's an axis of revolution, or it's a revolution, a volume of revolution, we know that all of our cross sections will be circles. And so we know what the area function is going to be. And really quick, I know my lower bound and upper bound, so I'm going to go ahead and write those. That is 0 and 3. Now let's get to the area function. The area function is pi r squared because our cross sections are circles. The thing is we have to write the radius in terms of x. So if you can see my circle right here, you can tell that if you took this top line and subtracted the axis of revolution, then you would get your radius. Whatever this number is and whatever this number is, if you subtract those two, you'll get the length of the radius. And so we have 3x plus 2 minus 1. That's the outer function minus the axis of revolution. And that's how I got my radius. And so when I plug that into my integral expression, this is what it would look like. That's right. 2 minus 1 is 1. Okay, the next one is the purple one. So I draw my little purple cross section in there. The radius for this one is going to be a little bit different because we have a different function. All right, so we have x plus 2, which is our inner function, right? Because this one right here is our outer function. So we have our inner minus the axis of revolution. We can simplify that too. So when I plug that into my integral, we square the radius, right over here. It says we square the radius. So we square this radius. It's x plus 1. That's because 2 minus 1 is, oh, no. Oh, I know. You were waiting for it. And then we got to square it. That'll be complete right there. Now, if I wasn't explaining this from the scratch, I probably would have went straight to this guy. All right. Because we know that they both will have the scalar, they both will have the same lower and upper bounds, we just have to subtract the two radiuses squared to get our final answer. And this one's not a calculator problem, and it's not one of those, which expression is this? So we're going to have to do all of this integration. So doing all this extra stuff, yeah, it works, but it is a lot of time. All right, let's get my radiuses in there and get some space. All right, so now my radiuses are in there. Let's square them. We have to square the 3x plus 1. So that's 3x plus 1 times 3x plus 1, and that's what I get. 9x squared plus 6x plus uno. And then I got to square x plus uno. So I go x plus uno times x plus uno, and I get x squared plus 2x plus uno. Wow, there's a lot of unos in this one. So if I plug this into my integrand, let's look how cute this guy looks. No, that guy does not look cute. That's a lot of terms to write. But don't take shortcuts, my stews, not on exams because you'll make mistakes. Trust. All right, so I distributed my negatives. Bam. Now I'm going to simplify that stuff some more after we make it all pretty and stuff with its calculus. We get an 8x squared plus 4x. Ooh, and those unos, they cancel themselves out. How exciting is that? All right, now we're just going to anti-derive this right here. So we get a 8 over 3 times x to the third. That's because we add 1 to the 2. Then we have to divide the 8 by that number, which is 3. And then we have our x squared times 2. Wait, I thought it was a 4. That's right. We had to add 1 to the exponent. Then we had to divide the 4 by that dose. Now, I'm going to go ahead and just cross out this 0 because both of these terms have an x term. And so when I plug the 0 in, they're going to just go away. They'll be zeros. So let's not bother ourselves with that. So when I plug in the 3, I get 8 over 3 times 27 plus 3 squared would be 9 times 2 is 18. And then when I do a little bit of math, I get 72 plus 18, which gives me 90 times pi, which is our answer.